Why does a ship's propeller sometimes sound like it's frying popcorn underwater, and why does that same effect steal thrust and chew up the metal? A propeller makes thrust by throwing water backward, like a water jet. But if the pressure around the blades drops too low, the water flashes into vapor bubbles. Those bubbles make the blade lose its grip, and when they collapse, they hit like tiny hammer blows. Forget the idea that the propeller pulls the ship forward by grabbing the ocean. What it really does is change momentum. Water comes in slower, leaves faster, and that backward stream carries momentum away. Newton handles the rest. If the prop pushes water back, the water pushes the ship forward. And it's not literally a screw drilling through water. Each blade is shaped like a wing, just in water instead of air. As it spins, one side of the blade creates lower pressure, the other side higher pressure. That pressure difference is what produces force, and the blade's angle turns that force into forward thrust. Now here's the trap. To make more thrust, you usually spin faster, increase blade angle, or demand more power. That makes water speed up over the suction side of the blade, especially near the tips. Faster flow means lower pressure. Drop it far enough, and water can't stay liquid anymore. So it boils, but not from heat. It boils from pressure. Tiny pockets of vapor appear, cavitation bubbles. You'll often see them start as a cloudy patch near the blade tip or near the leading edge, then they grow and get dragged downstream. And the moment vapor covers part of the blade, that section stops working properly. A blade is designed to push on liquid water, not on vapor. Cavitation effectively reduces the blade's usable area and wrecks the smooth flow. More turbulence, less pressure difference, less efficient thrust, while you burn the same fuel. Then the bubbles collapse. As the vapor cloud moves into a higher pressure region, it implodes. That collapse makes sharp pressure pulses, noise you can hear far away underwater, and vibration you can feel through the ship's structure. That's why cavitating props can be loud and rough. Worse, bubble collapse near metal can create tiny, high-speed microjets of water that slam into the blade surface. Over time, that causes pitting and erosion, like sandblasting, but generated by the water itself. A prop can literally get eaten alive. Cavitation is most likely when the prop is heavily loaded, rapid acceleration, high RPM, shallow water, rough seas, or when the hull's wake feeds uneven flow into the prop. Even small pressure drops from disturbed inflow can trigger bubbles, especially at the tips where speeds are highest. So how do engineers fight cavitation? One big move is more thrust at lower RPM, bigger diameter props, or more blades spreading the load. Skewed blades smooth the pressure pulses. Better blade shapes reduce extreme low-pressure spots. And sometimes a duct, like a Kort nozzle, helps at low speed by guiding flow and boosting pressure at the prop. The goal is simple: avoid dropping pressure below the vapor point. So a propeller makes thrust by accelerating water backward, but if pressure drops too far, cavitation forms, steals efficiency, makes noise, and damages metal. Next question: why do some torpedoes and race boats actually use supercavitation on purpose, and how can that ever be faster?